Hey everyone, welcome back to our channel. I'm Yomesh Gupta. In this video, we are going to talk about server-side events. It's a very common topic that comes up in system design interviews, plus it's also used in your day-to-day web apps. A lot of people, when they come into interviews and they present this technology or recommend this, they don't have really experience with it. So I thought I'll do a short video where we'll go over what it is, what are the pros and cons with the compared to comparative technologies like WebSockets, long polling, where exactly it makes sense to implement server-side events, and we'll also see a live use case where this makes an ideal candidate. We'll implement a basic implementation and we'll see how we can get it working. So without wasting any time, let's get started. So first things first, where exactly it makes sense in a system design interview to talk about technologies like server-side events, long polling, WebSockets, and so on. So in an interview, in a high level design discussion where you are recommending tech stack for the web app you are building, there you can talk about this technology. Or in a low level design, when you are in an interview discussing a use case, maybe building a Google Calendar. Now in that we want events from the server, then what technology should we use? Should we use long polling? Should we use WebSocket? Should we use server sent events, and why? So that is what we call trade-off analysis, that we'll pick up a potential candidates and we'll discuss which one makes sense and why. Now, in a system design interview, there could be, or in your web apps also, there could be multiple use cases where different technologies make sense. Like, let's say you can see on the screen, we have notification, dashboard updates, payment gateway status check. Now, notification here doesn't necessarily mean real-time notifications, which could be possible in a social media app. It is more like that you want some updates as and when they happen, or maybe once an hour, once in 2 hour dashboard update, some sort of chart update, or let's say payment gateway status checks. Now this is more like, let's say you go to a app like Swiggy, or you go to app like Zomato, and you make a payment. Now once, while making a payment, you're redirected to the payment gateway, and once you have done with the payment, you go back to the original app. Now there is that loader screen that shows you that they are processing your pace transaction. They're checking, was it done, what was the status, and so on. Now the payment gateway might be telling the original app using webhooks or something, so there is a delay. Now since there is a delay, we need to wait till our system is updated, and we know this is short lived, that maybe for a couple of seconds you want to show a loader screen where we are checking. So in that case, something like long polling makes sense. Now what is long polling? The same mechanism which I just described, that there is an endpoint on the server and the front end keeps on pinging that endpoints to check if there are any updates. Now this could be getting notifications, or this could be like on a loader screen getting the updates, like if payment gateway is successful, if the transaction is successful, and so on. Now, another set of use cases could be something like chat application, maybe Telegram, WhatsApp, or collaborative editing like Notion, Google Doc, and so on. And other things would be like financial trading platform, live gaming, peer-to-peer, where it's basically where we need bi-directional data flow and two entities are communicating between each other. For this technology, there is something for this use case, WebSockets make sense, which is a two-way communication. Like you can send data from one system to another. There could be a server in between, or there could be a peer-to-peer connection. Now the all the technologies I'm talking about, I'm giving a very high level overview. There are uh, pros and cons to each and one. Like for long polling, it's usually used in a system. It's the easiest to implement because you're just polling, you're doing an HTTP request to an endpoint. So it is used in legacy systems, or where you don't want any fancy implementation. But it's not efficient in resource utilization, because you have a continuously request going to the server again and again, and when you scale up, then it can bring down the server. Now when it comes to WebSocket, there could be trade-offs, like implementation could be complex. How would you maintain it? Auto recovery, those kind of things would be here. Now the third type of functionalities are, which are real time in this case, but unidirectional. Let's say India Australia match is going on, and you have something like you're on Crick Info or ESPN, or maybe you're on something like Times of India, where you see a live commentary. Now the data is flowing from server to client. you can implement long polling here, but let's say you are making a request every 5 seconds. Now within that 5 second, couple of things happened, so you might miss, so there could be a delay here. You can implement WebSocket, server sends the data to the client, and but here client doesn't need to send any data back, so bidirectional data doesn't really make sense. Then you have social media updates or stock tracker updates or live auctions. The basic thing is, as and when things happen, the server needs to tell the client that something happened, update the UI. So this is unidirectional data flow from server to client, and this is what we call server sent events. That is, like just explained, that if let's say uh, Virat Kohli scored a century and we want to show it on the client. Now either client can constantly poll, or server, as and when some update happens, it sends the data to the client and we update the UI and we show update the live commentary. So this is about pretty much about the three long polling, a very high level view of long polling and web sockets and server sent events. Now what's next? So next part is coding part. So let's implement server sent events and let's see how it's done. So let's see how server sent events are implemented. Like I explained earlier, we'll use a live example here. Let's say we are building an interview on a real world live commentary app. There is a sporting event going on, and as and when the commentary happens or something happens on the ground, we need to update the UI here. So if we go back to our app, we just have a normal Express server that is currently running, and we have a title and some comments. I'm using some starting data. You can assume we are consuming this from some third party API or something. And now this is our front end, which is basically rendering the commentary. We have all the UI. We just need to hook it up using server sent events. So let's first implement the server. So what I'm going to do is that I'm going to say app.get. Let's say our endpoint is events. It will take two parameters, request and response. Now inside this uh, chat, this copilot is giving us already a bunch of code. So let me just explain quickly what's happening here. Let me comment this out for now. So what we are doing here is that we are setting a bunch of headers. We are saying that the content type is text slash event stream. Basically, you are telling the browser that this is a text based event stream where or text based stream where events would be coming in, and you have to consume that. We don't want to keep the cache, and we want to keep the connection alive. Yani keep alive. So that's what we are telling the browser, and we are flushing those. Now what we are going to do is that, let's say we are going to have an index which is going to be 0. We are going to create a set timeout. So we are saying interval, and we are saying set interval here inside this. What we are going to do is that we are going to say that if index is less than comments dot length. Right now my index is 0. If it's less than comments dot length, if it's less than 30, then I'm going to write it and send it to the client. So I'm just going to update this data. I'm saying json.stringify. Inside this we'll have the ID, which is, let's say, this index. Right now we'll have a title which we already have, which is India versus Australia live score. We are going to take a comment, which is comment dot comments index. These are the comments right now, and we also need to spend the timestamp. So what we can do is we can say time is equal to new date to local time string. We will call this, we'll take the time here and we'll send it to the client. So this is what we are sending, and if it is less than, if it is greater than, if we consume all the comments, we just clear the timer and we'll end the stream. We can remove this also for now. We can add one more thing here, that if on close, when it's closed, then we can clear the timer and end the, we don't need the rest or end here. We are just basically, as a sanity check, we are clearing the interval so that we don't have a leak here. Now this is a simple API. Basically you can use an npm package here, but for our case I'm just simply demonstrating the concept. So we are sending a bunch of headers. The headers are important, and we are sending the data, and once it's done we are closing the response stream, and when we receive a close event, then we are just clearing the timer too. So let's do the client side implementation and consume the API that we created on the server. Let me just clean up this also, we don't need this. And so on my client side I want to consume this. So what I'm going to do is that rather than this, I'll create a state called comments and I will consume it. This would be an array of comment where each comment will have id, title, comment and time that we are passing. And let's import this. So we'll have use state and use effect from React. Let's remove this one. Now we need to consume. So I'm going to do is on my mount I want to create a connection to the server. So how I'm going to do that, I'm going to create something called event source. Using that, it's a browser API that we will pass the URL here. Basically it is going to create a connection, a live connection, persistent connection to this particular URL. Now as a cleanup function, let's do that. As a cleanup function we want to close the connection on unmount, and whenever we get a message, so chat, this copilot is giving us the message handler here. So on message we'll get the event. From this event we will parse the data. This data is basically id, one, title, first ball, comment, first ball of the match and time and so on. And we are going to set it to our state. Now we are setting it first because we want to set it as the first uh, we want to show the latest comment as at the top. So that's why we are doing here. One thing we also can do is that whenever we have an error, that on error we want to console log the error and we want to close the connection. So event.source.close. So this is done. Let me just close and rerun this again, the client server. And if I go back here, if I may refresh, then we are making this events call. See, we are getting this match started. This is the first comment, then we are getting the second, so on. This is the live stream data. So this we make a get call to events, and this is a keep a live connection. You can see the content type as event stream, text space event stream, and we are getting the entire event stream. And as we are getting, we are updating the client. Our UI is updating, and this will, and as we know on our server we are sending the data every 3 seconds. So right now I'm mocking. If you can send the data as and when you get it from the your third party API or whatever is your actual data source. So right now see, this was the first, then on 43 we get this India wins the toss and chooses to bat and so on. So this is the live commentary which we are getting and we are showing into the client. And if we see our client side code, it was very simple. We are using this browser API called event source. We'll pass the URL. There are a bunch of options that you can send as a second param. You can go to MDM and read about it. Now when we get a message from the server, when we get a server sent event, we will just parse event.data. You can, I haven't added and try and catch or error handling. You can do that, if there is a, if you want to add retries or if you want to show some error thing, you can do that. And once you get the comment, we set it to state, and since we set it to state, the whole component gets re-rendered and it is getting printed. And if it's an error, we'll print the error and clear the connection or close the connection. Similarly, if this is unmounted, we want to close the connection. See, and our event stream is over now. We got all the messages and it says it's a 4, India wins the match. So we implemented the functionality, the server sent events. We have the server sending the data and client listening, and we are rendering the UI as we have seen so far. But can we do better? Because in our case, what's happening is that we are listening to an external store, and as and when that external store updates, we are updating the UI. So let's create a custom hook and I'll show you what we can do to make it better. I'll create a folder called hooks. Inside this, I'll create use commentary store.tsx. Inside this, what I'm going to do is that I'm going to use a hook provided by React that is, specifically designed to listen to external data sources. And here, that hook is use sync external store. This is any browser API, any external store you want to listen, this hook is very beneficial in that case. So we are going to use it to make our code reusable, so that let's say you want to integrate the same code at multiple places in the app, you can do so. So I'll create a method called use commentary store that we need. I'll just export it also, and inside this I'm going to return use sync external store. So it takes a subscribe method, subscribe, and get snapshot. I think basically this will give us, this is used to actually listen to the data, and this is just to get the data. So I will pass that. Let me create a dummy subscribe method for now. Subscribe, it receives a callback, we'll handle it a bit later. So we'll pass this, and for snapshot we are just going to return the comments. Now what is this comment? This is the actual data we want to store. So what I'm going to do is, we can say comments, let make it a let, this will be a comment, let's import that, and we are going to just return it. Comments.array, it's is okay, we will fix these errors. Now we want to fetch the data from the server. So what I'm going to do is that I'm going to just copy paste this everything here. I'm going to create a method called fetch live updates, and inside this I'm going to do the same thing. I'm going to uh, make a call to our API. Inside this I'm going to say, first we need the comment. Okay, we have that. Then we are going to say comments is equal to a new array where we'll have the comments and the past comments. So we'll remove this one, and on error we again want to close the connection and log it, so it works fine. So now we need to handle our subscribe method. Basically when we want to store it, we want to store all the subscribers. So what I can do is that I can say subscribers is a new set of of callbacks. Let me, or in this case let's pass no op, because we don't know what these callbacks are going to do. No op, which is no operation. Basically this is equal to this, I don't know what this callback is going to do. So subscribers dot add callback, will add a cleanup function here also, which is basically going to delete this subscribers dot delete callback. Basically whenever it's going to get called, let's say someone calls this use commentary store, we are going to store it as a subscriber, and whenever we get the data we are going to send the data out. So in this case what we can do is, we can create a method to send the data out called notify. Inside this what we are going to do is subscribers for each, and we are going to call back, and we can add it here. Now the only thing is left is to call this fetch live updates. So I'm going to call it here. So if I just recap, we created a method called use commentary store. This is basically using use sync external store. It takes two parameters, subscribe, which is going to, which is the actual data fetching or data listening method, and this get snapshot returns the data. I'm not supporting server side event, that is the third, server side rendering, that is the third optional param. We are not supporting that right now. Now what is we are going is that in subscribe, we are subscribe receives one parameter callback, that whenever something changes we need to call this callback so that React can send the data out. Okay, so that's why we are storing it in a set, and we are returning a cleanup function to delete it. We created a method called fetch live updates. In this we did the same thing, we created the event source to this particular URL, and on message we are updating our array, comments array, and we are notifying, basically we are telling everyone who's listening to this data that we have new data. So we call the callback, and since this callback is invoked, React will call get snapshot, basically this part, and returns the updated comments to whosoever is listening to this. So what we are going to do is that we are going to take this, and inside our app we are going to import this use comment store. Now let me remove everything else here. So inside this we are just going to use a use comment store, commentary store. Basically let me remove this, we don't need all this, we don't need this now, and this also. So we are just using this commentary store. Let me just for the sake of it rerun my server, and if I come back and if I refresh, we make a events call and we start getting the data, and the same behavior, we are start getting the data, and as we have the data we just update the UI. But we just abstracted out all the logic to this hook, which you internally uses use sync external store, which is specifically designed to listen and manage external data sources, which was the case in our scenario. And this is now reusable, that in anywhere inside my app, if I want to showcase live functionality, you can make it configurable. Maybe you want to pass some URL, you want some other event source, maybe not this one, so you can do that, you can configure as per your need. But this makes our code much better, that our main component doesn't need to worry about any business logic, that is abstracted out into a custom hook and it's taken care of. So this is the end of the video. I hope you were able to learn something new today and this video helped you in some way. um, as always, if you see value in it, then please do like, share and subscribe. There are a couple of links on the screen, so the topics I'm covering, these trade-off analysis or low level design things, uh, under system design you can read more about my high level approach and material regarding to system design using the first link, devtools.tech/fsd guide. This is the front end system design guide that I wrote. It talks about a framework to approach system design interviews, and how, what question you should ask, what questions you might expect. It lays out a framework. It's a very high level guide, so you can use it to better prepare for your interviews. You can go to that. If you want to book a session with me, talk about your journey, talk about my journey, or just interview prep, or want to discuss something, you can book a session called using the link topmate.io/Umesh Gupta. You can use the platform devtools.tech for interview prep. And if you think I missed something, something could have been done better, or need more clarification, then please do mention in the comments or reach out to me on any social platforms. Also, if you want me to cover anything new, any other topic, then please do share that. Do mention in the comments or social media, whatever you feel comfortable with. Write a mail to me. So till next time, see you, take care, bye bye.